Alright, this mini lesson is going to demonstrate how to solve quadratic equations by using the quadratic formula. In class we actually derived the quadratic formula. We started with a quadratic equation, and we completed the square on it to solve that general equation to give us the solution to it. The solutions turn out to be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that is what's become known as the quadratic formula. And it's used to solve every single equation that is quadratic, like the one in blue. Now, of course, we don't solve the one in blue. In fact, we have the solutions for that one in the light blue. It's right here. X is that. What we want to do is solve equations that have numbers in for a, b, and c. So let's look at a few examples. Here's an equation. It's quadratic. X squared plus 7x minus 5 equals 0. It is in standard form. Standard form just means ax squared plus bx plus c equals 0. And by having it in standard form and comparing it to the standard form model, we can see that a is equal to 1, the number in front of x squared, b is equal to 7, the number in front of x, and c is the constant term. It doesn't have any variable with it. So there's our a, b, and c values. Here is the quadratic formula again. You have to memorize this so you can pull it out as needed. And it is simply a substitution type problem. So let's start substituting. We go negative of, so there's my negative I've just put in. Then it says the b value. So negative of 7 plus or minus the square root of the b value squared, 7 in this case, minus 4 times the a value times the c value, all divided by 2 times the a value. Now it's just a simple case of cleaning this thing up. Now, of particular interest is this stuff underneath the radical. You should generally just calculate that first. You can use your calculator for it. You can use your brain. We'll simplify it by hand here so we can see everything in action. 7 squared is 49. Then comes the minus sign. Then I like to do 4 times 1 times negative 5. 4 times 1 is 4, times negative 5 is negative 20. So it's minus that 20. So this negative and this negative right there, those are the two negatives that are the same. And then this negative results in that negative 20. And so we can see that double negative creates a positive. And it's all divided by 2 times a, or 2. Generally, what I like to recognize when I'm doing this is as soon as I see two negatives, I know I'm going to be adding on to the b squared value. So in this case, I'd go 49 plus 20 right away. And so now I just continue to simplify. I get negative 7 plus or minus the square root of, I add the 49 and 20, it's 69, divided by 2 times 1 again, which is just 2. Now normally what we do is we also check to see if we can factor that 69 and find some perfect squares inside of it. That's 3 times 23. 3 is prime and 23 is prime. Neither of those are perfect squares. So in this case, there are my simplest answers. Keep in mind also those are two solutions. X is either negative 7 plus root 69, all divided by 2, or X is negative 7 minus root 69 divided by 2. We can get decimal values for that if we want to. I'm going to go ahead and get those so you can check to see if you know how to do it on your calculator. I'm going negative 7 plus the square root of 69. I get an answer for that numerator. It's a good number to remember or write down. That's about 1.3. Anyway, then you just hit divide by 2. And you get 0.65. Okay, and it's got a bunch of other decimals. This is clearly irrational, so this fraction here goes on and on forever, never repeating. So those two are approximately equivalent. Let's do the negative root 69, so minus negative 7 minus the square root of 69. get an answer for that numerator about negative 15 and divide it by 2. And that's negative 7.65. So there's their decimal approximations. In general, we want the exact answers, and we write it in the shortcut method. Let's try one more of these things. Here's another quadratic. I can identify it by the x squared, or in this case z squared. That's the highest degree or exponent in the problem. Step 1 is I want to get it in standard form. So I'm going to put the 6z or negative 6z squared first, then the positive 3z. I'm going to add the 8 to the other side, so it's on the left now. Okay. I can actually use the quadratic formula at this point, but I think it's much nicer to divide out a negative 1 from everybody, and that way I have a leading positive a value, which will be nice later on. So now that I've gotten the a value to be a positive 6, b is a negative 3, and c is a negative 8. Okay. Again, the quadratic formula for reference for you: negative b plus or minus square root of b squared minus 4ac all over 2 times a. And so again, I go negative of, what's b? Negative 3. I get a double negative. Plus or minus the square root of. I take the b value and I square it in my head. Negative 3 squared is 9. Minus 4 times a times c. All over 2 times a, which is 6. Okay. So our next step, I'm going to take these double negatives, make it a positive 3. I'm going to recognize I've got a negative and a negative, so they're going to make each other a positive when I multiply everything out. So 6 times 8, oh goodness. Let's do 24, 4 times 6, 24 times 8. Maybe 216. I'm going to do 4 times 6 times 8. 192. So this part is 192. Now I've got to add the 9 to that, so 201. Okay. And then you can start to check to see if that breaks down. Kind of depends on your workflow. 2 times 6 is 12. Okay. Let's see, I know it's divisible by 3, so I might try that. 3 and 67. I don't think 67 breaks down at all. Not that I can think of. So I think I'm done right at that point with my solutions, and there they are. Okay. Just for fun, let's go ahead and check this thing using the complete the square method so you can see you get the same answers. If I were to solve this by completing the square, I would first throw the 8 to the other side, and then I'd divide out the 6. I'm going to rewrite that 3 over 6 as 1/2. Z equals an 8 over 6, I'll write as 4/3. Okay. Now I'm going to determine what to add to make the left side a perfect square. If I take 1/2 and I cut it in two, that's 1/4, and if I square 1/4, I get 1/16. And so adding the 1/16 to the other side. Alright. Left-hand side now is a perfect square. Z minus 1/4 squared equals, and now I've got to get a common denominator here. 3 and 16, 32. I think I'll have to go with, 48, I guess. So I'll make these fractions both with denominators of 48. So 16 times 4 is 64 over 48 plus 3 over 48 gives me, I'll copy this all. Let's copy it. We'll paste it on another page so we can keep working. Gives me 67 over 48. Wow. Now I can square root both sides. Z minus 1/4 equals plus or minus the square root of 67 over 48. Now before I bring that, I can bring that 1/4 over right now, but I'm going to work on this radical a little bit. 67 over 48 both underneath the radical, so we can separate those. Let's see if that 48 factors as 3 times 16. I can take the square root of 16, so that's root 67 over 4 root 3. I don't want a radical in my denominator, so I am going to have to multiply by a root 3 over a root 3 to get rid of that radical. That gives me the square root of 21 carry 2, 18, 201 over 4 times 3, which is 12. Now I'm going to bring this 1/4 over, and so z equals 1/4 plus or minus the square root of 201 over 12. If I get a common denominator, it'd be 12, so I'd have to multiply this times a 3 over 3, and I'd get a common denominator of 12 at that point. And I end up with 3 plus or minus square root of 201 over 12. 3 plus or minus the square root of 201 over 12. We get the exact same answer. But clearly, this quadratic formula, which solved it in this space, is way better than completing the square, which took a couple of pages. I hope that helps. Your homework, by the way, was section 8, 162 through 168.